Okay, so for this one, number 21, well, what's different between 21 and the earlier questions is that we have an or statements right here. We have an or statements right here. So if you watched the video for number 18, I explained the difference between and statement and or statement. If you did not watch the video for number 18, please go ahead and watch it so that you know what's going on between an and statement and an or statement. So, so to go over this briefly, for or statement, that means we only need to fulfill one of these two conditions. We only need to fulfill one of these two conditions in order to have a true statement overall. Okay, so let's go ahead and try it out. So this is a pretty simple one. We say the one on the left, we just add 4 on both sides. So we have x is less than 6. And then we have to subtract 2 for the right-hand side, the inequality on the right-hand side. We have x plus 2 greater than 2. So we subtract 2 on both sides. So we have x is greater than, sorry, x is greater than 0. X is greater than 0. Okay, and again, this is separated with an or. Okay, and we're gonna go ahead and use a number line to represent our current inequalities. So we say, all right, so we have 0 and we have 6. So x is less than 6. And x is greater than 0. Now, again, it only has to fulfill one of the two conditions. Now, let me propose some numbers. Okay, let me propose some numbers and see if you can make sense out of it. So we say, can we do 8? Is 8 a solution, we say? Well, first, is 8 less than 6? No, that's not. So that would make this statement a false statement. I mean, let's go ahead and say false. Well, let's try the next one. Is 8 greater than 0? And we say, ding, 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 ding. Yeah, it is greater than 0. That's true. And remember that for or statement, we only need one of the two conditions. One of the two conditions to be true for the whole thing to be true. So we say, yeah, 8 is a good one, actually. 8 is a good one. So that means everything over here is a good one. Now I'm going to hold on to that, okay, so that we keep our picture a little bit more clean because we're going to test out some more numbers. So we say, okay, how about this? Let's say 4. Can x be 4? We say, all right, let's take a look. Can x be 4? So is x less than 6? We say, yes, it is. Okay, x is indeed less than 6. Is x greater than 0? And we say, yes, 4 is also greater than 0. So it makes both statements true. Wow, that's fantastic. We only need one of these two statements to be, one of these two conditions to be met. Now you got both. Wonderful, wonderful, wonderful. So we say, all right, 4 is good. 4 is good. What about say -2? Okay, would -2 work? We say, oh yeah, x is -2 less than 6. Yes, 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 that's true. It's conditions met. What about is -2 bigger than 0? No, of course not. Of course not. But again, do we need to meet both conditions? No, we don't. Just one of these two. So we say, oh, guess what? -2, it's also a good one. So one thing that we can generalize here is that, well, if you draw your number line, if it's an or statement, that means wherever the number line touches, covers, I mean, whatever the arrow covers is a solution, because that means it makes at least one condition true. So now, what's the solution for this one? Well, it seems like any number will work. Any number will work, even like, can X be 6? Can X be 6? Like there's an open circle right here, right? Can X be 6? We say, well, that's not going to be true for X less than 6, but hey, it is greater than 0. That's good. Well, what about 0? Can X be 0? There's an open circle right there. And we say, well, let's take a look. It's 0 less than 6. Yes. Is 0 greater than 0? No. But we only need one of these two conditions to be met. And we have a true statement. So we say, oh yeah, 0 is good too. So that means everything on this number line, it's good. So what's our solution set? We say, oh, for set builder notation, we'll say, well, X such that X is equal to all real numbers. Or with interval notation, we'll say from -infinity to infinity, because everything is fine. Everything is good. Everything is fantastic. Okay, everything is fantastic. Okay, so that's number 21. That's an or statement. So if you want to generalize, okay, between the and or statement, I think we can have this following generalization. We can say if it's an and statement, you want to make sure that the arrows would overlap. That would give you the solution set. For or statement, you want to make sure that the numbers you are picking is at least covered by one arrow. Okay, if it's overlapped, fine, but we have to have at least one arrow covering the values. If not, it's not a solution. So for number 21, we have all real numbers. Okay.